Hello, and welcome to another E2 tutorial session. We will continue with the basic time series methods, but now we're looking at part two. In part one, we focused on what a time series analysis is and the basic time series methods. We touched on, or we mentioned all four of them, which is the naive forecasting, the moving averages, exponential smoothing, and linear trend analysis. We also focused on understanding what the naive forecasting method is all about, and we did our very first example on naive forecasting method. Now, in this second part, we would focus on the moving averages and exponential smoothing method. What is moving average? Basically, this method focuses on calculating the average of a fixed number of past periods to smooth out fluctuations and forecast future values. And exponential smoothing method basically applies a weighted average of past observations, right? With an exponentially decreasing weight. So it has a constant, which is called alpha, and it uses that as a weight to apply it to forecast future values, right? The emphasis for exponential smoothing is on the recent um, data, right? That's what it places a huge emphasis on. These two models, right, where we basically refer to them as smoothing models, right? Because they try to smooth out whatever fluctuations that is present in your time series data. So we'll look at an example and we'll try to use these two methods to analyze the given data in that example. All right, here's our example two, right? Where we get to use two different methods, moving averages and exponential smoothing. So still continuing from that Roscoe store, right? Now what they want us to do is to use a 3-period moving average to forecast sales, right? For weeks 4 to 11. But some additional stuff would construct a time series plot. We'll try to talk about the type of data that is present in that plot. And then in part B, would utilize our exponential smoothing approach, and we've been given alpha 0.1, which is that weight that we have to apply when doing the analysis. We would also try to forecast the accuracy using our MSE, and then finally try to forecast or predict what the sale will be for month 11, right? So we're still working with the same data set that we use in example one, right? Um, Hopefully, this would give you an idea of how to do moving average and exponential smoothing. Having said this, let's go over to R and start off the analysis. One thing I want to do is to clear out my console or my R environment so everything is looking fresh and nice. So if you don't know how to do that for the global environment, just click on this broom icon here and then click on yes, it's going to clear everything out. Also for your console environment, click on that broom there and it will clear everything out. That ensures that when you're calling a particular variable, it doesn't use a variable from a previous analysis that you've done, and that would give you a wrong answer and all of those different things, right? So we don't want any of that to happen. So I am, before I have the time series data. I'm just going to change this to moving average and exponential smoothing approach, right? Before I look at bringing the data in, just some additional stuff we need to put there. So this is part A, which is moving average. And then there's some packages we do need to install, right? I already have them installed on my computer, but if you don't, I am going to just put a note here, right? So we need the So I am commenting it here because I don't want to install it, right? But if you do need to install it, um, just take out the hashtag and then install it before you load the package, right? So here I am just going to call the library, which is DPL, right? So this is it here, right? It basically helps us with doing some data um, manipulation. So that's it there. And then the second library would be the zoo. All right. So basically those two um, libraries is what we need to um, use, right? So the zoo library also contains some forecasting models in it, and we need to use the exponential smoothing uh, method from it. So, and it really helps us with working with time series data that is either ordered or an irregular time series data. All right, so we have that um, there all written out. Let's go ahead and bring in our time series data. All right, so that's our time series data here. I would just put, say, load the libraries. All right, so I run it, this. Also, if you don't have, just realize if you don't have the zoo library installed, you would want to do that as well. So I'm just going to put it here. Right, so that's it. So also, try to install that. Um, and then since we're dealing with the same data set, this is our DF and our data frame, um, the week and the data, just same thing from what we have here, right? Same thing, no difference whatsoever. So I'm just going to run it, right? And we can see that data frame is loaded here. So if I open this, we could see our data set here, all of the 10 weeks and all of the sales data that we have there. I could change it and say, instead of saying data, let's change it and let's say sales, right? Because we know it's sales, right? To keep things consistent with the previous one. So I'm just going to run that again, and all it would do is just modify it. Instead of saying data, it says sales, right? That's all. So uh, now the next thing we do want to do is, let me call this import the data, right? The next thing we want to do is just the descriptive statistics, right? We didn't really do that in the naive part, but we get to do it in this method too, which is the moving average, right? So for our descriptive statistics, we just use the summary function, df. And if you run that, you can see that the average sales is around 120, right? That's the average sales. So for the 10-week period. So I just put an interpretation. The average sales over the 10-week period is 120, right? That's that. And then the one thing our question asks us is to create the time series plot, right? So this is basically the chart that you use to visualize time series data. It is a line chart, right? But I often, or I prefer to call it a time series plot, right? Because on the x-axis, it's going to show you the information with respect to time, right? So let's do that plot. So we're interested in week, and then df sales, and then the type we wanted to use like like some circles to connect the different data points. And we want the line color to be a blue, right? You can put any color that you like if you want, right? And then the X lab here is just basically a label for the X axis, so which is week. And then for the Y label, we want it to be sales. And then the the main is basically the title of the chat, right? We want it to be uh, Roscoe Stores Sales Plot, right? That's what we want it to be. So if I run that, you can see it there. If I click on zoom, this is basically what it looks like, right? So we can see that there's a horizontal pattern here, right? Or there's some sort of stationarity because our average was 120, right? So our data points kind of like hover around that average of 120 for sales. So that is your time series plot. You can see the time aspect there as well as the sales on the y-axis. So I'm just going to put an interpretation. All right, so that's my interpretation. Now, the next thing we go to is to now calculate the 3-week moving average, right? That's the next thing we want to go into, right? And basically what this is doing is that we're going to have to skip the first 3 weeks of data, right? And then we would now use that first 3 weeks to calculate for week 4, right? So basically the first 3 weeks will be empty, and then week 4 would now be week 1, 2, 3 divided by 3, right? And subsequently, we'll just be doing it that way. So I'd write out the code first, I would run it, and then from inside the data frame, I'll basically show you how it is doing that calculation. So I'm just going to be silent a little bit, so I can, focus and write the code and not have to make any mistakes. So what I'm doing there is the sales for week 1. I'm going to add it to the sales of week 2, and I'm also going to add it to the sales of week 3, and I'll divide it by 3 because we're looking at a 3-week moving average, right? Remember, our question asked us for a 3-period moving average. If you were doing a 4-period moving average, then that means you have to add 4 weeks or 4 periods, and you have to divide by 4, right? That's basically what that means. So I'm just going to copy this so I don't have to write it again. All I would do is to change the values in there. So you can see how it's dropping, right? I don't have 1 showing on my second one anymore. Now it's going to 2, and I've added 4 into it, right? So the next one will just be 3, 4, and 5. So it's going to, so and 5. It's going to be dropping like that. And remember, we have what? Um, we have 10 observations. So we're not going to include um, observation 10, right? Because remember, um, we skipped the first three rows, right? We skipped it. So, right. So that's that. And our next, okay, before I go in there, let's run this. So it says we have an error. Did I close that bracket? Yes. So, mhm. 1, 2, 3. Let's see. Mhm. Ah, okay, okay, okay. I know where the error is. So I shouldn't have put a comma on this last one. So that's where my error is. So if I run this. Okay, good. So that has basically gone through. Have you noticed that our number of variables have increased from 2 to 3, right? So we started the code with just 2 variables, which is week and sales. So now let's go look at it and let's see that average sales 3. So yes, sometimes you would have this error, but you need to look at the error and basically understand what is going on, right? So for me, R is telling me that my argument 11 is empty, which basically means that my row 11 is empty. And that was because I put a comma here, right? I put that comma here. So it was thinking that it's expecting me to put another line of code, which no, I am not supposed to do that, right? Because I only have 10 rows. So once I took out that comma, you can see that my code worked. So have you seen it? Remember I told you your first three columns will be empty, right? And then if we do 110, 115 plus 125, if you add that divided by 3, it gives you this. And then for this one, it would be 1, 2, 3, right? If you add this 3 here, 1, 2, 3, it gives you this next one. For 123, it would be 1, 2, 3. It gives you 123. So that's basically how you would have done it, right? In order to get the average sales, which is like our forecast error. So let's continue. Now let's calculate the squared errors because that would help us in calculating our uh, MSE. So we're basically only interested in the not sorry, in the week. I put months. So for the weeks, right? So basically, we're only interested in like from week 4, 5, 6, 7, 8, 9, 10, right? Not week 1 to 3 because there's no information there. I should bring this down, yeah. Square error. So if else is so mm, yeah, take the square that down. So basically what we're doing is that we're telling R that hey, any row that any row in the third column, which is average underscore sales, right? That's what this here is saying, right? If it's NA, just drop it, right? Don't focus on it. All we want you to do is focus on the row that says sales that doesn't have any NAs and then subtract it from the average sales and then take the square. That's basically what we're telling R to do in this line of code. So now have you seen? We've gone from 3 variables, now we have 4. We started with 2, we added one more, now we've added another one, right? So if we go there, you can see the squared error. It did not calculate it for the first 3 weeks. It has started from the the fourth week. What it has done is 120 subtracted from 116, and then it takes the square. That's the answer there, right? So now we compute our MSE. As usual, you have to exclude the initial weeks. All right, so we're doing our mean square error. We take the mean of the squared error that we calculated. So for missing value, we put true so that R knows that, hey, there's missing value in that squared error columns. Don't include it when you're finding the mean, right? And then the next thing would just be to output the MSE. All right, so you can see our MSE is 69.84. So uh, 69.84, right? That's our MSE. Now, the next thing we want to do is now go into part B, which is to find or to calculate the exponential smoothing approach, right? So we're still using the same data. So I'll just put that note in there. So that same data set from lines 13. So now our constant, which is alpha, has been given to us as 0.1. So we do need to write that out there, right? So alpha is 0.1. So we have that there. Now our exponential smooth would be rep. Just want to let you know that, hey, if there's any NA, just don't focus on that. So sales. So you should basically start with the first, you start with the first row, right? That's what we're trying to write there. So and then we're just going to use like a very simple for function, and take the length of our sales column, right? And put the exponential smooth for a particular row, then apply the alpha value, multiply it by the sales for the previous row, which is I minus 1, plus 1 minus the constant or the weight, which is alpha, and then multiplied by the exponential smooth of the previous row. All right, that's what that does there. So just a simple for function to help us do that calculation. So I'm just going to run this. All right. So it has done all of that here for us, which you can see it there, right? So we're now going to use that new information to calculate our MSE. So our MSE XP smooth. We just take the mean, the actual sales data first, but we'll focus on rows 2 to 10. Just remember we asked the smoothing model to start from row 1, right? So 2 to 10. And then we will, oh, I'm supposed to put a double bracket here because I have to take the square. So we would take the square, yeah. So there's a double bracket there. Then the MSE of the exponential smoothing model. Okay, so if we run this, all right, so you get your exponential, the MSE for exponential smoothing model as 108. So we're still going to do the same thing, comparing the two methods. So, but let's just say output the MSE, which is 108.25. Okay, so we just need to see which method is the best at the end of the day. So I am just going to copy that if else function from our previous code, so I don't have to type that again, and just save us some time and just bring that in here, right? So we have that, better method comparison. We use the if else. So if the MSE of the moving average, which is part A, right? Where did I write it? Ooh, okay. I forgot to write it. So this is it here. So part A, moving average, right? So the MSE of part A, which is this, right, is if it's less than the MSE of the exponential smoothing, right? We'd say 3 moving average, or it should say exponential smoothing, right, is the best. So we try to list the results. So our MSE of moving average, MSE of exponential smoothing, and then we've asked it that use this if else function we had in 61, right? And then tell us which one is the best. So let's run that. Okay, so obviously the best one is the 3 moving average, right? Because it has a smaller MSE when compared to the exponential smoothing. All right, so that is basically it for the moving average and exponential smoothing approach. I hope this um, helps you learn how to do these two other methods as part of the basic time series forecasting methods. Please um, do not forget to subscribe, like, and maybe comment in this video if you have any questions. Also turn on the bell notifications, right? That's very important. So you get all of the different video updates. Um, Thank you so much for watching the video all the way to the end. We appreciate it, and thank you for watching.